It's 2:45, 2:46, so let's get started. This is session 13C, Data Mastering in the Cloud. I'm going to introduce, without much further ado, Dr. Stonebraker, Dr. Michael Stonebraker. I think most of us know him by reputation, but Dr. Stonebraker, it's all yours.
Oh, thank you. Okay, so I'm Mike Stonebraker. I'm on the faculty at MIT down the street. And I'm also the founder of Tamer, which does data mastering. So I'm going to talk about data mastering and moving data mastering to the cloud. So I'm going to spend a couple minutes reminding you what data mastering is. And then I'm going to tell you why you should move it to the cloud. I'll then tell you of the gazillions of cloud architectures, what's the best one to use. I'll talk a bit about why cloud native is a good idea. And then I will have one slide on how to deal with real time. And then I'll talk about templates and why they are useful. And I'll plan on ending within an hour. So here we go. So first thing I don't have to remind you of is your enterprise is full of data silos. I guarantee it, if your enterprise has more than 100 employees, chances are it's full of data silos. Why is that? Well, enterprises empower independent business units. So you're entrusted with going off and trying to create a business selling refrigerators to the Eskimos. You're given a budget and management says, I'm going to shut you down unless you can deliver within time X. So time is of the essence, and you do your own thing. You set up whatever data you need, and otherwise things just move too slowly, because if you are going to coordinate with all kinds of other people, then all decisions have to go through God, and business agility goes out the window. So I guarantee you that your enterprise is full of data silos for this reason. There is huge business value in integrating these silos. So just for example, GE, the big conglomerate, has a purchase order system. So what's a purchase order system? Well, you walk up to it, you want to buy some paper clips, you type in your ID, and it spits out a purchase order, and you take it down to Staples and you get your paper clips. So that's what a procurement system does. Anyone want to guess how many procurement systems GE has? The ideal answer is one, of course. Anyone want to guess?
How many employees?
Thousands and thousands. 10. The answer is 75. And so the CFO of GE figured out the following, which is if you're one of these 75 purchasing agents and you can figure out what your 74 counterparts negotiated in terms and conditions for example, Staples, and then if you demand most favored nation status, that's worth $100 million a year, which of course isn't spare change. But to do that, you've got to integrate 75 independently constructed procurement databases. Now, why are there 75? Well, chances are GE bought a company and it came with a purchase order system. And instead of taking the time to integrate it with other stuff, they just left it there. So chances are M&A contributed, new business, ... Anyway, 75. So how do you do silo integration to get the $100 million? So you need, after the fact, to integrate independently constructed data sets for common entities. And please, if you get nothing else out of this talk, tattoo this on your brain. Independently constructed schemas are never plug compatible. I have never seen independently constructed plug compatible schemas no matter what. So if you have one, bless you. I've never seen one. So if you want to do silo integration, then what do you have to do? Well, move the data sets to a common place, whatever you want to call that. You've got to get data sets into common units. So for example, if you are the HR person in Paris, I'm the HR person in New York, you have employees, I have employees, you have salaries, I call them wages. Your salaries are in euros after tax with a lunch allowance. Mine are gross in US dollars. And so you've got to somehow get them into common units and meaning. Previous talk talked a bunch about that. And so let's assume you normalize into common units of meaning. Then you've got to line up the various columns that mean the same thing, line up the tables that mean the same thing. And then a biggie is that as a general adage, 10% of your data is wrong. And so if you're going to put it together, you've got to clean it. And one of the favorite things that everybody talks about is in scientific data, you often see minus 99. That's usually a moniker for null. And you can't just take the average of a field that includes minus 99 coding for nulls, because obviously that will create garbage. So you got to do data cleaning. Chances are you want to enrich the data with more attributes. So if you want more signal, if you can possibly find it, you can get that from metadata, you can get that from wherever. You can get that by joining with other stuff, etc. Once you get that, then you come to the key thing, which is you've got, in GE's case, they have 75 contracts with staples. You've got to figure out which in all these data sets all refer to staples. And that's not as easy as you think, because there are no global keys, ever. And for example, Merck, the drug company with an address in New York, Merck with an address in Berlin, Germany, are those the same entity or not? The answer is it turns out they're not. They're completely independent companies. So it's trickier than you think to perform entity consolidation, but you've got to consolidate duplicates. As often as not, you want to find golden values for clusters of records that refer to the same entity. If you have Mike Stonebraker and you have 3 or 4 addresses for him, which one do you want to use? So often that's the next step. Maybe you want to classify employees as part-time or full-time. So you want to perform classification. And you want to do all of this while the data is changing out from underneath you. And so you have to perform ongoing stewardship. So this is what silo integration entails. And it involves a pipeline of some number of the previous steps and is called lots of things by various of the companies that are exhibiting in the hall. We'll call it data mastering. So everybody, I guarantee you that you have this problem, or that your company has this problem, and there's huge upside value in solving it. So what does it mean to do data mastering at scale? It means you got to do it for a lot of data, a lot of entities, lots of data sets, ... So let me give you a few examples. It turns out Toyota Motor Europe is a customer of Tamer. And so if you buy a Toyota in Spain and you then move to France, then of course you want to get warranty work in France for the car you bought in Spain. Perfectly reasonable to move around the EU. So Toyota is organized so that there's a Spanish distributor and a French distributor, and they know nothing of each other. So Toyota does not want to develop amnesia when you move to France. So they are interested in mastering Toyota customers across all of Europe. And so this is to provide better customer service. There's 30 plus million customers in 250 databases in 40 languages. This is what I mean by doing mastering at scale. So definitely a challenge. Now, if you learn nothing else from this talk, you must do data mastering at scale as a machine learning problem. There is no other technology that will scale. And in the hall, there are several companies that do data mastering using a rule engine, and that does not scale. The people who have done this before know that all too well. So if you need to do data mastering at scale, do not use a rule system. And it is almost universally done, except for Tamer, by the guys in the hall. Okay, why doesn't a rule system work? So here's an example of a media company in Los Angeles. So what they want to do is they have several different properties, a whole bunch, lots of them. So they are in the business of creating and licensing content. So if you license content, then you collect royalties. But the problem is content is not identified in any easy way. So there's the Star Wars Episode 6, there's the Empire Strikes Back, et cetera, et cetera, et cetera. There are no unique keys, and they have a ton of content. So to normalize all their content and remove duplicates, they bought the traditional Kool-Aid and they started writing rules. They happened to do this using a homebrew system. They wrote 200,000 rules. And if you're not giggling, please giggle now, because that is completely unmaintainable, absolutely unmaintainable. The standard wisdom is you can write 1,000 rules and be able to understand what's going on. You twist my arm, I'll give you a few thousand. There's no possible way anyone can understand 200,000 rules. The technology just does not scale. They've spent 26 person years doing this. So think of this as a $5 million project over a while. And it is a cesspool. It is quicksand because it takes forever for them to add a new data source. And it takes equally forever for them to change anything. So why is it that there are 200,000 rules? Well, funny you should ask. So I'm sorry this isn't all that readable, but this turns out to be a display from Tamer's platform GUI. Turns out to correspond to B&G Foods Incorporated. And you can see that there are a bunch of data sets, which is the thing on the left. And B&G Foods is 5 different possible notations. There's an address, and you got a whole bunch of different ones of that. There's a city, you got a whole bunch of different ones of that, and so forth. So imagine writing a rule system that basically puts this stuff together correctly. So you say, okay, I can do that in 10 or 15 rules. That's fine. So now let's look at Deutsche Bank Capital Funding Trust 8. So it's just another enterprise in this same integration sphere. And so again, you have 5 different names, 5 different addresses, a bunch of different cities, and so forth. So you can imagine, well, I can write 10 or 15 more rules. And the trouble is that this just doesn't scale, which is every time you want to add a new kind of thing, it takes a bunch more rules. So you run out of the ability of the technology to scale very quickly. So if you have a small problem, by all means use a rule system from the vendors in the hall. If you want to scale, meaning to Toyota kinds of numbers, then you've got to use machine learning because a rule system simply won't scale. Now, I have no problem with you using the result of a rule system as training data to a machine learning system. You could conceivably use ChatGPT to create training data to a machine learning system. So I have no problem with using the traditional technology as input to an ML system, but using it without an ML system is going to be death. So use an ML system. Okay, so data mastering is compute intensive. ML systems grind up tons of computer time, even if you use a rule engine and ignore my advice, those grind up a lot of computer time. So there's a batch ML mastering project at time 0, and every time you change stuff, you've got to incrementally change stuff. So computing needs are huge at time 0 and go up and down thereafter. Okay, so why is this a good cloud application? Well, you're going to move everything you possibly can to the cloud no matter what. And you're going to use decision support stuff will come earlier, and COBOL legacy code may never move ever. So why are you going to move stuff to the cloud? Well, James Hamilton, one of my works for Amazon, he claims, and I have no reason to dispute this, that he can stand up a server for 25% of your cost. And so if you have raised flooring in Cambridge, Amazon doesn't do that. Why do I know that? Well, I'll give you the Dave DeWitt vignette. Here's Azure data centers as of 2 years ago. They are shipping containers in a parking lot, power in, chilled water in, internet in, otherwise sealed, roof and walls optional. They're only there if you need them for security. And this is sealed, so as boards go bad, you configure them out of your running system. If too many boards go bad, in comes the forklift. You take the shipping container away and replace it by another one. There's no possible way you can compete with that kind of cost structure. So the cloud guys are going to simply kill you in terms of cost. And the answer is join them, don't try and fight them. And so this all becomes a migration problem. You're going to migrate everything you can to the cloud over time, inevitably. If you don't, then your cost structure is going to be worse than your competitors, and that will be bad. Okay, so data mastering is an ideal cloud application, absolutely ideal. Resource needs vary. Get 100 processors from Amazon today, get 10 tomorrow, all works just fine. It's very data intensive. Data may well already be on the cloud, but basically if you have variable computing needs, the cloud is ideal. Okay.
Can you escape? Just hit escape once on the. There we go.
Okay. Okay, so now if you're going to move stuff to the cloud, you're going to move your data mastering and 100 other applications. So this is going to be in your future in general. So how do you do it? Well, there are several alternatives. Number one, my least favorite way to do it is lift and shift. Take whatever you've got now on-prem, jack it up, move it over, and drop it on the cloud. It will simply regenerate all the sins of your predecessor in the cloud. So you can certainly do that, but that's not going to make much difference. Whatever issues you face on-prem, you're going to face them on the cloud. And it's not going to get you elasticity, because you want to be able to allocate 100 processors today, 10 tomorrow, and to do that, you're going to have to refactor your application. So this is not going to work out very well, but it's what lots of people are presently doing. So if you work for a company that's doing lift and shift, I would highly advise you to go find another employer. Okay, so the second thing you can do is what's called platform as a service. So somebody else, maybe Tamer, whoever, runs a cloud instance on your behalf. So you are now not running an instance, and so you'll have lower DBA costs, but unless you do something else, you're not going to get the 100 nodes today, 10 nodes tomorrow. So you can certainly rent cloud instances from whoever you want to, and that will be better than doing lift and shift, because you will have refactored some, but it won't get you the elasticity that you're looking for. So the best solution by far is what's called software as a service, which is to say somebody else, whoever it is, runs a whole collection of cloud instances and allocates, and has multi-tenancy built into their architecture, so that they put you on three systems when you need a lot of resources, one if you don't, and so forth. So use multi-tenancy to allocate clients to nodes, and whoever's running this software as a service agrees to charge you only when you're using resources. So if you're doing nothing, it costs 0. If you need 100 nodes, it costs 100. If you need 10, it costs 10. This is exactly what you want. Pay for the resources you use and only the resources you use. And of course, they've got to agree to scale up to whatever your needs are. And so if you need 1,000 nodes, then they have to agree to provide that. This gets you what you want, which is elasticity. It's the only thing that gets you what you want. And of course, this is the most work for the vendor, because he's got to have a multi-tenancy system, he's got to do bin packing, et cetera, et cetera. So this is a lot more effort on behalf of the vendor that you're using, but it's what you want. Okay, so here's my opinion. Please, please do not do lift and shift. You have a once in a generation opportunity to refactor your stuff. Please, please take advantage of it. Please fix the sins of your predecessor. Your successor will appreciate it. So don't do lift and shift. Platform as a service, widely supported, but doesn't do everything you want. Software as a service is far and away the best option. As you move to the cloud, choose a vendor that supports software as a service. Okay, what about cloud native? Well, you may well run on AWS, you may well run on GCP, you may well run on Azure. If you run on GCP, Bigtable may be your best option. If you run on AWS, they may ask you to use Redshift, ... So your cloud solution will entail a database, one or more of them, one or more computing platforms, et cetera, and by and large, if you can use the vendor's preferred system, chances are you'll be better off than if you use one lowest common denominator. So, in my opinion, use the best solution on each cloud. If you're cloud agnostic, then you use one solution on all clouds. And cloud native is guaranteed to be a better idea. But of course, it's more work for the vendor. So, and by and large, almost certainly you are going to want to run multi-cloud because otherwise you are locked into some given cloud vendor, and no one thinks that's a good idea. Okay, what about one and done? So you do a mastering project, and it's almost never the case that it's one and done. At time zero, you have a mastering project. However, whenever your source data gets updated, then your whatever you did at time zero gets slowly out of date. So you need an incremental data mastering strategy. And please, for goodness sakes, don't rerun your time zero batch solution incrementally. That's an opportunity to give the gross national product over to AWS. So incremental mastering should be linear in the number of records that have been updated, and if your vendor doesn't do that, get a different vendor. Otherwise, this is going to be ridiculously expensive. Of course, as you update stuff, gradually your data drifts away from the semantics that started off at time zero. So incrementally fixing stuff will eventually become suboptimal. So every once in a while you need to rerun from scratch. And you need to decide when to do this and do it as infrequently as possible. So this stuff gets a little tricky. And when an ideal vendor should give you some advice on when you've drifted. When you've drifted enough that it's a big problem. Okay. What about templates? Well, the thing I find fascinating, absolutely fascinating, is that Tamer does lots and lots of mastering projects. And by and large, there's half a dozen entities that most everybody is mastering. So you're mastering customers. In the case of General Electric, you're mastering suppliers. Turns out Carnival Cruise Lines, which is the guys with the big white boats, it turns out Carnival is in fact 9 different companies that have been merged together. So Holland America is part of them, and Costco in Europe is part of them. So it's a merge of nine different cruise ship companies. Each of them has their own parts database. So you have spare parts. You have some parts on the boat, some parts on the dock, some parts in the warehouse. And Carnival Cruise Lines has 9 of these systems, 1 for each of these cruise lines that they've been put together. And of course, the schemas are never compatible. So you have to do mastering to master parts, because what they really want to do is, if Holland America has the part that you need and you're Carnival, you'd like to get it from them if it's closer than what Carnival has. So you want to master parts. You want to master projects. The Fin Services guys all want to master customers. If you want to do cross-selling, you really want to master customers. So there's very popular entities. So wouldn't it be nice if you didn't have to start from scratch with your mastering project? Wouldn't it be nice if your vendor had a preferred schema, which you could use or change, pre-built data cleaning routines, pre-built, pre-trained model with whatever open source data they can get their hands on that you can add to, and that just gives you a leg up. So in general, choose a vendor that's got templates for the mastering tasks that you have to deal with. Okie dokie. And obviously, start from something rather than start from nothing. That's totally obvious. And so choose vendors who have templates for the entities you will need. Okay. So what have I told you so far? Data mastering at small scale is easy. Use whatever you want. If you want to master 100 records, whatever. Do it on your wristwatch. Data mastering at large scale is almost guaranteed to fail unless you use an ML system. Because if you use rules, you're going to be in the same situation that the content provider was in, writing 200,000 rules. If you start off down that path, please resign and go work for a different company, so your successor has to deal with that quicksand. And data mastering at large scale is, I didn't say it was easy. And so you better put your best people on working on this. And please, please, please do not use a domain-specific product, one that only works, for example, on customer data. So you need one that will master whatever you want to do. And if you can, move it to the cloud right now and use a product that's cloud native and runs a software as a service model. That will save you a lot of pain and suffering and save you a ton of money in the process. And mastering isn't easy. It's rarely one and done. You have to deal with drift, which is the data sort of slowly drifts away from the initial model. the model may well drift. So when you started, you had most of your customers in Massachusetts. You've now moved to customers in New England. Whether they look like Massachusetts customers, who knows? Training data is always really costly and in short supply. Why is that? Well, inside the enterprise, you can't use Mechanical Turk on public data on the web, because that doesn't look like enterprise data ever. So you've got to use enterprise data, your enterprise data. My favorite example is my brother was a career Army officer, and for a while he was in the 101st Airborne Division. And in that unit, there's the notion of a leg. And a leg is simply somebody who was not parachute certified. No one else uses leg to mean that. So you need training data that is particular to your application, because otherwise you're going to create garbage. So if you use ChatGPT, ChatGPT is tuned on the internet in general. Almost certainly that doesn't look like your stuff. And so training data, how do you get it? Well, the problem is that you've got to deal with the Merck in Germany and the Merck in New York. And chances are that takes a knowledge worker in your organization to be able to make those kind of calls. And the trouble with all that is that knowledge worker doesn't report to you. Chances are the lowest common ancestor of he and you is the CEO of the company. So getting training data is always tricky. And by the way, that makes doing a deep learning model really challenging, because deep learning requires a shit ton of training data. So be very cognizant of training data and how you're going to get it and how much it's going to cost. And for goodness sakes, you have to deal with this issue because a rule system will not scale. Just will not. And so put your best people on this particular aspect of the project, because this is probably the most important thing. And for goodness sakes, don't try and boil the ocean. The last thing you ever want to do is at time zero say, well, I have 7 different entities, let's master them all at once. That's almost guaranteed to be a recipe to fail, because you will have a learning curve to go through, and you want to start out small and start out on a project that is most likely to succeed, which means your project won't get canceled before you deliver something. Okay. As I say, there are a bunch of companies offering rule-based systems out in the hall. Tamer is not one of them. We have an ML solution, and go check them out if you want to learn more about how to do ML. And of course, they're happy to give you demos. They're out in the hall too. And with that, I'm done, and I'd be happy. I'm sure I've made some people mad, so now's a good time to attack.
Questions? Let me give you the microphone.
Yeah, thank you for the talk. Very much in line with some work we're trying to do within Department of Navy, and wanting to know from your experience, what is the general timeline for that upfront establishment of those key entities and the relationships you're going to need to build those training data sets? Any thoughts on that?
Sure. In fact, one of Tamer's customers is the Black Hawk helicopter program. And believe it or not, the Black Hawk is used by 3 different services, the Army, the Navy, and the Marines maybe. And believe it or not, I cannot make this up, they have 3 completely independent parts databases. This is the same friggin' helicopter, identical. And so they want to share parts. Why? I mean, it makes perfect sense. So they have a mastering problem at scale because there's a shit ton of parts in a Black Hawk, and so getting training data, is the biggest problem. And so it's very situational. You may have some hanging around. You may have some rules that an expert can generate, which will generate, run the rules. That'll generate you some training data, which of course may not be accurate. By hook or by crook, get some training data. And that will probably be the gating factor to the success of your project. And so worry about that early and often.
So I have this is a great talk, by the way, and I agree with a lot of what you said, and it makes a lot of sense. I think my question is, how do we talk about this to non-data people, right? I'm dealing with folks that a basic string comparator in a rules-based makes them they start shaking because they're concerned about false positives, and it's really hard to explain this stuff to them and to get them to trust. They feel like the rules-based gives them some control. You can set very tight standards, and yeah, there's more clerical review required. There's an operational impact, but how do you build the trust to say, hey, we're going to leverage this model and get them to buy into it?
Okay, so as I wander around the world, I just meet a ton of people who've tried that and it's failed. And so the conventional wisdom is that from anyone who's done it is that won't scale. And so I think you just say it's guaranteed to fail. And you can point to lots of examples like the Hollywood content guys where it's basically failed. And so, and I think if you work for a company for which that's not persuasive, then you probably work for the wrong company.
My question is, so I work for a state agency that provides healthcare.
Mm-hmm.
Healthcare data is, I wouldn't say different, it's just maybe infinitely more complex than customer parts and providers, right? So the question I have is, how many successful implementations of mastering at scale have you observed in the healthcare space?
Well, the healthcare guys are late adopters of absolutely everything. So, and so I'm not sure Tamer has any healthcare customers, and it's really too bad because, in my opinion, if I go to my doctor and he takes an MRI and says, "Here are your symptoms. Here's your MRI." What I'd like to know is everybody else in the country that has MRIs that look like mine and has symptoms that look like mine, and what was their diagnosis and what was their treatment.
And your doctor should know that.
Absolutely, and getting there, I think is I mean, there's just huge upside to moving in that direction. And you're dealing with unbelievably conservative entities. And so I don't have a good solution.
If I may follow up real quick. So this is a call for help. when you get the example of Toyota, like 30 million customers, 250 dealerships across Europe, right? For a single patient, a patient deals with upwards of a dozen doctors, another dozen clinical providers who are not doctors, and maybe half a dozen or so pharmacies. Scale that over 300 million people in the country. Think about the number of points of entry for that customer's identity information. So just resolving the customer identity as an entity for mastering purposes becomes a problem at scale. So just
However, one bright note is that Veterans Affairs doesn't have any of your political problems. And so I would start there and see if you can make a Veterans Affairs system work at scale.
Okay, my question. With all these new possibilities, are the silos you started your story with, are they now behind us? How, or are the silos still continuing in the future?
I think there's two. I mean, going back to GE, politically, GE wants to leave the silos in place because that's politically expedient. Ideally, you would get rid of them because once you master the data, you actually have the ground truth. And so ideally, you would put it in one place, and that would, so anyway, the goal of everybody should be to stamp out silos.
Yeah, but you acquire a new company.
Sure. Stamp them out faster than they grow. Because otherwise, the successor in your job will have a worse problem than you have.
Okay.
I have a question regarding schema building, because I 100% agree, like building schemas independently, you cannot match them afterwards. But at the same time, we talked before, you said like building this domain model doesn't really work out. So what's your solution or takeaway on that?
Well, I think I have a lot of gray hair, so I remember the sins of the past. So I think the answer is you've got to stand on the shoulders of your predecessors, not on their feet. And so I think there's no reason to try something that is known to have failed. And so I think the answer is doing point mastering solutions is not an enterprise-wide model. And so anyway, constrain the problem as narrowly as you can and get that to work. And then try the next domain and see what happens. So I'm a huge believer in incrementalism. Don't try and boil the ocean. If you're going to try something new, try it at small scale. And make sure it succeeds before management kills the project.
Question back here and then up here.
So I'm curious about your opinion related to architecture and data modeling, and if something like star schema changes in the cloud, or is it still relevant?
I'm a huge fan of star schemas or snowflake schemas. And my biggest disappointment was when I started Vertica, which was a data warehouse company. I said, obviously everybody's using a star schema because that makes perfect sense. And of course, that was only true about a third of the time. And so people are, data modelers are really stupid. I mean, they create awful schemas. And so I think the answer is, to the extent you can run a star schema, please, for God's sakes, do it. because the reasons not to are usually stupidity. Well, that's stated a little harshly, but
Professor Stonebraker, just a quick question. There's a lot of reference data out there, right? So a customer or supplier is an enterprise. There's some master list out there because the companies need to be registered.
yeah.
How does reference data come into that machine learning and to validate and get that golden data that you try to get to?
Oh,
How
very
important does it come to?
straightforwardly, because lots, like Tamer has a partnership with Dun & Bradstreet. And D&B has a huge database of enterprises and their D&B magic number. And so the answer is you do a fuzzy join to D&B's data, and that gives you an added column, which is your best guess as to the D&B number, and you just use that in your ML system. So basically, get all the extra data you can, get all the extra signal you can, and then just feed that into your ML model. And the more signal you can get, the better off you are.
One more question. Hopefully we have time for this. So appreciate your candor. It's very refreshing. Thank you for that.
I'm not a salesman. So I don't wear a suit.
Yeah. This may fall in the category of sins of the past, but what would you say to folks who are like, all I really need is an entity resolution tool, and how is maybe data management different from that? And perhaps secondly, what would you say to folks who say, all we need to do is construct an ontology and then make our data conform to that? Are those valid approaches?
So your first question is an entity resolution tool. That's basically what Tamer does. So the whole question is, if you can find an ML entity ML entity resolution tool, that's a great idea. Those are very scarce in the hall outside. Number two is, what about just doing an ontology? The trouble with an ontology is it comes back to the previous talk, which is, just for example, MIT has a data warehouse. They have 2,400 tables, and it's got all the standard stuff you would expect. It has professors and students and classes and grades and all that stuff. So the trouble with that is that, there's campus addresses, there's home addresses, there's office addresses, there's student home addresses, there's student campus addresses. The ontology gets pretty big very quickly, and lining that up with 2,400 tables is really a challenge, because the problem is the DBAs of this 2,400 table database, MIT administrators come in and say, I need XYZ. I have a report I want. Can you run it for me? And they have no idea how to find stuff in 2,400 tables. So I think that's fairly challenging. And again, if I was going to do it, I would view it as an ML problem.
Do we have more questions?
Could you elaborate on the domain approach that you're not too confident in? If I heard the question correctly, because I missed what you said.
Well, the MIT data warehouse has 2,400 tables, a few terabytes of data, and probably 10,000 columns. I mean, I don't even know how many columns. And so modeling that requires you to first understand 10,000 columns. And the current warehouse administrator don't know that. I mean, I think, and I mean, at scale, it's hard to expect a human to grok that much stuff. To me, it's back to the same problem as rule systems, which is at a big enough scale, it becomes really challenging. And I think the other thing, just in all honesty, just between us girls, the MIT administration doesn't get world-class IT talent, which I think is part of the problem also.
Does anyone else have a question in the room? As a data modeler who's in the Inman camp, so I guess is that smarter than star schemas? I'm not sure. I would handle the address problem. I've got some things I can tell you about how we did it in banking, but this has been a great session. Thank you very much. Dr. Stonebraker, do you have anything else you'd like to say? Or?
Oh, thanks. Oh, I love the questions. So
thanks, everybody.
Thanks for your time.